turning our struggles into strength, one concept at a time. Welcome once again to Mastering Competence, the ultimate platform for mastery and guaranteed excellence in the new lower competence-based secondary curriculum. This is a series designed for all students who want to learn, to revise, and to excel together. In this channel, we feature competence-tailored discussions of especially past papers to enhance our familiarity to question approach and help us excel together. So today, we shall be solving another mathematics number, item 2 of UCE 2024 mathematics paper. Allow me to give us a prayer before we can start embarking on this number. Let us pray. Almighty Father, King of glory, we worship you and we adore you, Father. Thank you for this day. Thank you for the gift of life. King of glory, we call upon you to come and give us wisdom, to give us knowledge and understanding, Father, that everything we are going to discuss here, let us be able to understand it, Father Lord. Let it get stuck in our memory, and whenever we come across such numbers, Father Lord, we shall excel in them and we shall glorify your name, because you're the one who has given us the wisdom. We give you all the praise, we give you all the honor. In Jesus' name I've prayed, amen. So today again we are still trying to solve item 2 of the mathematics paper UCE 2024. And item 2 is what we are going to look at today. And item 2 is set from the theme patterns and algebra. So item 2 will simply be derived from the topics that are listed under this theme. And these are the following topics. We have sequences and patterns, equations of the line and curves, algebra 1 and 2, loci, mapping and relations, inequalities and regions, equations of the line, simultaneous equations, linear programming. So item 2 of UCE 2024 is displayed on your screen, and this is how the item goes. A tailor makes school uniforms for boys and girls. The tailor makes at least 80. When you're reading this scenario here, you have to pay close attention to each and every single statement that is made, because once you understand the terms that they are using in the scenario, it will be very easy for you to approach the scenario with ease, especially numbers that are relating to linear programming. Linear programming is a very easy number, but once you misinterpret the terms that are used in the scenario, you are not going to be able to maximize all the scores for that item. So as you're reading the items that are related to linear programming, you have to be very keen to understand each and every statement used, because they always mix up and twist these words to confuse the learner. So pay close attention as we are reading this number. So a tailor makes school uniforms for boys and girls. The tailor makes at least 80. So the word here we are saying is at least 80. So the tailor makes at least 80 sets of uniforms for boys and not more than 100 sets for girls. Not more than. So when we see here at least 80, what comes into our minds? It means that the tailor makes 80 and above. 80 and above. Then here we are seeing that for the girls, the tailor does not make more than 100 sets of uniforms. What does that mean? The number of sets of uniform for girls do not exceed 100. In other words, 100 is the maximum. In other words, the tailor makes at most 100 sets of uniforms for girls. The scenario continues to say, each set of uniform for boys requires 4 meters of material, and each set of uniform for girls requires 3 meters of material. The tailor has at most 600 meters of material. So the keyword here is at most 600 meters of material to use. So the amount of material the tailor has to use does not exceed 600. 600 meters is the maximum that she has. The scenario continues to say that tailor makes a profit of 8,000 shillings on each set of uniform for boys and 6,000 shillings on each set of girls uniform. The tailor is not sure of the number of sets of uniforms to make in order to maximize profit. So our tasks are as below. Part A. Express the tailor's conditions as inequalities and regions. And part B is requiring us to show the feasible region of the tailor's condition on a Cartesian plane. And then part C says, help the tailor to determine the possible number of sets of boys and girls uniforms that should be made to maximize profit. Hence, state the maximum amount of money the tailor is likely to make. So when we look at this scenario here, we are realizing that there are a number of topics that they have combined together in order to come up with item 2. For instance, we are seeing that there is linear programming, which is majorly what has been examined, and then also there is some bit of equations of the line, because we shall be required to generate equations of the line. So we are also seeing that this has been examined. Then inequalities and regions, which is what our part A is about, and then also there is some part of algebra in that item. So what does this show you? It shows you that it's not that they are going to pick all topics here and then they make up one number. They just select some specific topics from the theme, and then they combine them together, and then they bring for you an item. Item 2 won't only be about linear programming. Another day you might find when they have picked different topics. But as for today, we shall be solving a number about linear programming. So let us go and we start tackling the number. I told you last time, before tackling any number, the first thing that you have to do is to number your work. If you don't number your work, you're going to lose marks because of silly things such as failure to number your work. So the first thing that we are going to do is we are going to number our work. So we have numbered our work as response to item 2, part A. Now part A was requiring us to do what? What was part A requiring us to do? Let us check and we see. Part A was telling us to express the tailor's conditions as inequalities and equations. But in order for us to express the tailor's conditions as inequalities and equations, we need to have variables. So what are we going to do? We are going to define the variables for the sets of uniform for girls and the sets of uniform for boys. So that is the first thing that we are going to do right now. So we are saying let X represent the number of school uniforms for boys and let Y represent the number of school uniforms for girls. So now if you are reading the scenario carefully, the scenario was telling us that the tailor makes at least 80 sets of uniform for boys. So now for boys she makes 80 and above, because at least simply means 80 and above. So 80 and above is the statement that is going to help us to generate our first inequality. So we are going to come here and then we are going to say A, and then our A will be X, which represents the number of uniform for boys, and they are telling us she makes at least 80. So that means 80 and above, and 80 and above can be represented using greater than or equal to, meaning that she cannot make less than 80 uniform, but she makes either 80 uniforms or above 80 uniforms. So the inequality symbol that we have to use here is greater than or equal to 80. So this is our first inequality, that the tailor makes at least 80 sets of uniform for boys, meaning that the tailor will make 80 uniforms but not less than 80. So they can either be 80 or more than 80. So we have finished our first inequality. And when you go back to the question, they are telling us that the tailor does not make more than 100 sets of uniform for girls. So what are we seeing here? Not more than 100 sets of uniforms. And what does not more than mean? It means that she does not exceed 100. So she can either make 100 or below 100. So this statement here helps us to generate our second inequality. And since y represents the number of uniforms for girls, we are going to say our second inequality here is y is less than or equal to 100, meaning that the tailor makes 100 and below, but she does not exceed 100 sets of uniform for girls. And the scenario was telling us that the tailor has the boys' uniforms require 4 meters of material, and each set of girls' uniform requires 3 meters of material, but the tailor has at most 600 meters of material. What does this tell us? It means that the available amount of material is 600 meters. She does not exceed that. It is what she has. So that means that 600 meters of material is what the tailor is having, and the amount, okay, like the sets of uniform for girls and boys that she's going to make will not exceed the 600 meters of material. So now this statement here helps us to generate our third inequality, and our third inequality here will be 4x, which is the amount of material that is needed for each boy's uniform, plus 3y should not exceed 600, because 600 is the only amount of material that the tailor is having. But now remember, the number of uniforms cannot be in negatives. In other words, the tailor has to make at least 1 and above uniforms for either boys or girls. The tailor cannot make uniforms which are in negatives. So it is also a must for us to write these two inequalities here of x is greater than or equals to 0, meaning that the tailor has to make at least a uniform for boys, but she won't make uniform for boys in negatives. We cannot have uniforms in negatives. And then the last one will be y is greater than or equal to 0. So what we are seeing here on our screen are the inequalities that we have generated for part A of our task. So now we have finished part A. But then another thing that we also need to remember is that in our question, they told us some statement that we are leaving out that is going to help us to find the maximum amount of money, the maximum number of uniforms, or the number of sets of uniforms for boys and girls that the tailor should make in order to maximize profits. So we need to go and extract out that statement, because that statement is going to give us the expression that is going to help us to figure out the maximum number of uniform sets to be made by the tailor. In other words, that expression is what is referred to as the objective function. So we are going to write it here. Our profit equation. It is not part of task A, but I'm just writing it here so that it can be a reminder to all of us. And they told us that each set of boys' uniform, she makes a profit of 8,000. She makes, what does the scenario say? It says that the tailor makes a profit of 8,000 on each set of boys' uniform and 6,000 on each set of girls' uniform. So this statement here is going to help us to derive our objective function, or the profit equation, or the expression that is going to help us to figure out how many sets of uniform that tailor should make for each category of students. So the profit equation here is going to be, it's going to be 8,000x plus 6,000y. So this is it, 8,000x plus 6,000y. This expression here is going to help us to find out the maximum profit that she can make from the sets of uniform that we are going to figure out later. So now we have solved part A of the task that was given to us. So now we have to proceed to part B, and we find out what part B was requiring us to to do. And our part B here was telling us to show the feasible region of the Taylor's conditions on a Cartesian plane. So let us see how we are going to work out that part of the item. So when we come here, we are going to see that before we can, our task of part B was requiring us to represent or to show the feasible region of the Taylor's conditions on a Cartesian plane. But we cannot do that if we have not formed linear equations from the expressions that we had written before. So these are the expressions that we had written for part A. And now from these expressions here, we have to generate and formulate linear equations that are going to help us to show the feasible region of the Taylor's condition. So before you go to the graph, before you show the feasible region on a Cartesian plane, we have to form linear equations from the expressions. So that is what we are going to do right now. Now we are going to form the linear equations from the expressions. So our first expression, I remember, was x is greater than or equal to 80. So when you're forming the linear equations, what you have to do simply is that you have to replace the inequality symbol with an equal sign. So from this one here, we are going to have x is equals to 80. Now x is equals to 80 can easily be drawn on a Cartesian plane. But remember, because of the inequality symbol that we are having here, we are having the inequality symbol of greater than or equal to. So when you have inequality symbols such as greater than or equal to or less than or equal to, it means you have to draw a bold line. You have to draw a bold line, which is also referred to as a solid line. A solid line. But however, when you come across expressions with inequality symbols such as greater than, less than, the line is going to be a broken line. It will be a broken line. But now, for our sake here, what we are saying is that our first expression here is x is greater than or equals to 80. So when you're changing it into linear equations, you replace the inequality symbol with an equal sign. And when you replace it with an equal sign, you have to ask yourself, before I replaced it with an equal sign, what was the inequality symbol? Does this inequality symbol require me to draw a bold line or a dotted line? A broken line is the same as a dotted line. Because our inequality symbol here has the equals, that means that we are going to draw a bold line. And then our second expression, I remember, was y is less than or equal to 100. So we are having y is less than or equal to 100. And now for this expression here, what we have to do again? We have to replace the inequality symbol with an equal sign. So what are we going to have as our linear equation? We are going to have y is equals to 100. But because the inequality symbol here is a less than, that means when we are representing this line on the Cartesian plane, we have to draw a bold line. Are we together, my friends? Yes. And then we go to our next expression. Our next expression, I remember, was 4x plus 3y is less than or equal to 600. Now this is where things get interesting. So our other expression, our third expression was 4x plus 3y is less than or equal to 600. Now for this case here, what a learner is expected to do is to figure out the boundary lines. You have to generate coordinates that the line is going to pass through. So for this case here, what we usually do is that we are going to draw a small box. We are going to draw a small box, and then we are going to try and figure out the boundary lines or the coordinates through which the line is going to pass. Now for expression 3, what a learner is simply supposed to do is to generate any number randomly so that we can be able to get coordinates that are going to be plotted and the equation of the line for expression 3 will pass through. For instance, we are saying that here is x and then here is y. So we are going to put here 0 and we put here 0, meaning that when x is 0, what will be the value of y? And when y is 0, what will be the value of x? For instance, for the first part where we are saying when x is 0, what is the value of y? So remember, in our expression here, I told you when we are trying to generate linear equations, we replace the inequality symbol with an equal sign. So we are having our expression now as 4x plus 3y is equals to 600. And we are saying when x is 0, what will be the value of y? So where there is x, we are going to replace it with 0. So 4 into 0 plus 3y is equals to 600. And we are saying 4 times 0 is obviously as 0. So this side will remain with 3y is equals to 600. You divide both sides by 3. So we remain with y is equal to 1 is equals to 200. By 3 here 1, by 3 here 2. So y will be equals to 200. This is telling us that when x is 0, the value of y is going to be 200. So now we have already got our first points through which line 4x plus 3y is equals to 600 is going to pass. So our first coordinate here will be 0 to 100. Then we proceed to find out what is the value of x when y is 0. So when y is 0, what is the value of x? That's what we are going to find out here. So our expression remains 4x plus 3y is equals to 600, right? Let's leave this one aside. Let me underline it because the answer of the previous working. So when y is 0, what will be the value of x? So we shall have here 4x plus 3 into 0, because the value of y here is 0, will be equals to 600. So now here what are we having? We shall remain on this side with 4x is equal to 600. We divide both sides by 4. By 4 here 1, by 4 here 1. Our x will be equal to what? We are getting 60 divided by 4. Let us reduce by 2 here 2. By 2 here we have 300. And then by 2 here 1, by 2 here we have 150. So our value of x is equal to 150. Meaning that when y is 0, the value of x will be 150. And that is our second point that we are going to plot. That is 150, 0. So now these points here are going to help us to draw the line 4x plus 3y is equal to 600. And it is going to be a bold line. It is going to be a solid line. Reason being, this inequality symbol here of less than or equal to requires us to draw a bold line because of the equal to. You get it? It is an inclusive set. But now, one thing that I don't want us to forget, is also the values of the expressions that we told you earlier about, that the uniforms cannot be in negatives, right? That's why we have to include the expressions of x is greater than or equals to 0 and y is greater than or equal to 0. So these expressions here, they also have to be changed into linear equations. When we change them into linear equations, what are we going to get? Let me first erase this part here so that I can show you what we are going to get. So when we change these ones here to linear equations, we are going to have x is equals to 0 and y is equal to 0. But x is equals to 0 is the same as the y axis, and y is equals to 0 is the same as the x axis. not so? But when we shall be labeling our axes, we are not going to label them as x is equals to 0 or y is equals to 0, but rather y-axis and x-axis. So the y-axis and x-axis also have to be drawn as bold lines. They have to be drawn as bold lines because the uniforms that they are going to make cannot be in negatives. One thing that I forgot to tell you, my dear friends, is about defining the variables. Some people wiseacre and they want to use other letters. It is preferably x and y that should be used in mathematics. Some of you will say let the number of boys' uniforms be s, let the number of boys' uniforms be t. You are wiseacring. Don't bring your k, don't bring your q. Use x and y. Please use x and y. You're going to land on biased teachers who are not in their moods. Perhaps the guy has fought with his wife at home, then after you're writing for him in the paper, let the number of uniforms be k, let it be q. The guy will cross you mercilessly. So let us stick to x and y. Now, having formed our linear equations from the expressions, the next thing that we now need to do is what the task was requiring us. The task was specifically telling us to show the Taylor's conditions on a Cartesian plane. The feasible region of the Taylor's condition is what we are supposed to show on a Cartesian plane, and that is what we are going to do right now. Here is our graph paper, our Cartesian plane on which we are supposed to represent the Taylor's conditions. On this graph here, we have to show the feasible region of the Taylor's condition. Now, what is the feasible region? The feasible region simply means the unshaded region that we are going to come up with after drawing the respective lines that we have come up with. Now, we are going to draw those lines and we are going to shade them according to the conditions of the Taylor. In other words, according to the inequalities that we generated. Now, that unshaded region we come up with is what we refer to as the feasible region. It is going to help us to find out the maximum number of sets of uniform that Taylor should make, and it will also help us to figure out the maximum profit that Taylor will make if she is to utilize those number of uniforms. Now, the lines that we are supposed to draw have been displayed here on your right hand side. I've drawn them for you in a table, and I'm going to show you a very simple trick that can help to save you time in case you're caught up with time in examinations and you're attempting a linear programming number, because sometimes you might be caught up in time and you won't be able to prove it, which side of the line should be shaded and which side of the line should be unshaded. So I'm going to show you a simple trick of doing it, and then I will also show you the right way of doing it. So the first line here that we are supposed to draw is x is equal to 80. So x is equal to 80 can easily be drawn on the graph. Let us draw that line and we name it. So our line x is equal to 80 has been drawn here on the graph. Now, one thing that I want to tell you is you should draw a line and you shade it immediately. Don't first wait to draw all the lines, then after that you begin to shade them. It can create some kind of confusion, then after you get lost in the paper. So what we are going to basically do is we are going to draw each line and we are going to shade a region for that line. Now remember, here on our left hand side you are going to see the line and also the inequality for the line. So remember, according to the inequality that we generated, we realize that x is greater than or equal to 80 is the condition that we are supposed to prove, and we figure out which side of the line should be shaded. Now, this is the trick that I was telling you. If the line is not passing through the origin, one thing you should know is that the part of the line which faces the origin is always less than. So, like for instance, on this line of x is equal to 80, when you look at this line here, we are having two parts. We are having this part here A, and we are having this part here B. So what I'm trying to tell you is that the part here, which is the part B, this part here, is facing the origin. Our origin, we all know, is found here, not so? So now the part of the line which faces the origin is always less than. The part which faces the origin is always less than. And the part which faces away from the origin, that is to say part B right here, is always greater than. So you just come here on your right hand side and you see the inequality symbol of the line x is equal to 80. So when you look at x is equal to 80, the inequality symbol here is x is greater than 80. So what does that mean? It means that we have to shade remember, we want the part that satisfies the inequality, right? So in other words, we want to keep the area where x is greater than 80, and the area which is less than 80, we are going to shade it away because it is the unwanted region. For us, we want to keep the area that satisfies our inequality, and our inequality is very clear that x has to be greater or equal to 80. And remember, we said earlier that if the symbol is greater than or equal to or less than or equal to, we have to use bold lines. We have to use bold lines. So we already drew our x here, and our x equal to 80 is a bold line. Now we are trying to shade the unwanted region, and I'm telling you again, the trick is very simple, that the part of the line which faces the origin is always less than, and the part that faces away from the origin is always greater than. When you know this trick, it will always save you time from having to choose a point and then you have to put it into the inequality, then after that you prove whether it satisfies the inequality or not. But as long as you know this trick, it will be very easy for you to shade quickly and save time. So now when we look at our first equation here of x is equals to 80, and the inequality symbol was x is greater than 80, that means that the part of x which is greater than 80 is what we want to keep because it satisfies the equation. And because I told you the area facing away from the origin, that is area A here, is greater, and the area facing away, facing towards the origin, which is B here, is always less than. So what does that simply tells you? It simply tells you that we are going to shade area B here because it is facing towards the origin, and that means it is less than. Just as you can see here on our x-axis, that the numbers 100, 120, 140 and so forth are greater than the numbers 60, 40 and 20 which are facing towards the origin. The scale itself shows the evidence that the numbers here which are facing away from the origin, apart from 80, they are greater. Meanwhile, the numbers that are facing towards the origin, 60, 40, 20, are less than. And now because our inequality symbol here indicates a greater than, that means we are going to shade the less than side of line x is equal to 180. That means we have to shade the area B here. This area B here, which is facing towards the origin, we are going to shade it. So using this trick, you can easily save your time in examinations by just knowing that the part of the line which faces the origin is always less than, and the part of the line which faces away from the origin is always greater than. And this trick only works if the line does not pass through the origin. If the line passes through the origin, you have to choose a point either above or below the line, and you test it into the inequality expression that you generated. So with that being said, let us shade area B. So now we have shaded our area B, that is the area which was facing towards the origin. Now the next line that we have to draw is the line y is equal to 100. So let us draw the line y is equal to 100, and then we identify which part of line y is facing the origin and is facing away from the origin. So this is our line y is equal to 100, and it is a bold line because it has the equal in the. Now this is our y is equal to 100, and it is a bold line because according to the inequality that it possessed, it was having less than or equal to, and we already know less than or equal to is a bold line. Now let us find out which part of line Y is facing the origin and is facing away from the origin. So when you look at line Y, it is very evident here that when you look on your y-axis, 80, 60, 40, 20 are less, and then 120, 140, 160, 180 and above are greater. So we are seeing here that area A is less than while area B is greater than. I told you earlier the areas always facing the origin are less than, and the areas facing away from the origin are greater than. So that means we are supposed to shade area B, because the inequality here for our y is less than or equal to 100. That means the less than side, which is side A, satisfies the equation because our y has to be less than 100. But since side B is greater than 100, it is the unwanted region, and we are going to shade it away. And now we have finished shading the unwanted region. That is the region which was not satisfying our expression. The region that we have shaded was greater than 100, and we have kept the region which was less than 100 because it satisfies our equation. Now our next line is 4x plus 3y is equal to 600. But remember, I've given you here the points that we are supposed to plot so that we can come up with that line. So we are having the points 0, 200 and then 150. So we are having 0 on x-axis and 200 on y-axis. This one here is x, this is y, and then this one also here is x and this is y. So we are having here also 150 on x-axis, and then we are having here 0 on y-axis. So let us draw those lines, and then we also shade them. We shade the unwanted region. So now this is our line 4x plus 3y is equal to 600. And now we again have to identify which area is facing the origin. And we can see very well here that this area here, area A, is facing towards the origin. That means it is less than. And then area B of the side of this line is facing away from the origin. That means it's greater than. But here, about this line of 4x plus 3y is equal to 600, we can see that the inequality symbol here is less than. That means it is the one that satisfies the inequality. In other words, this side A satisfies our inequality. We want to keep the less than region, not the greater than region. So that means that area B has to be shaded away. And now we have finished shading the area that is unwanted, or the area which does not satisfy the inequality. So our feasible region is displayed here as a triangle. Now there's another thing that we should not forget, is that remember earlier we said they have to produce at least one uniform. In other words, the tailor cannot produce negative uniforms. And now that means that we also have to shade the regions which do not satisfy the inequality of our last two expressions. That is, x is greater than or equal to 0 and y is greater than or equal to 0. And remember, I told you that because the uniforms cannot be negative, that means that we have to shade the negative side off, because uniforms cannot be in negatives. And remember, this inequalities here, this linear programming is a practical question. These are things in real life. We cannot have negative uniforms. That means we also have to shade the part of our scales, that means that we have to shade the part of our scales which that means that we also have to shade the negative sides of the x-axis and the negative sides of the y-axis. And I forgot, by the way, to label the axis. I can't believe I made that mistake, but I'm telling you this, never make that mistake. You should always label your axis. Now for us here, we forgot to label the x-axis and the y-axis. That's a blunder. If you forget to label the x and the y-axis, they can even cross your whole graph without marking it. So let us label our x and y-axis, and we shade the negative sides which do not satisfy the conditions. And there, now we have finished labeling our axis, and then we have also shaded the unwanted parts of the axis, that is to say the negative sides of the axis. So now what is the next thing that we are supposed to do? We are supposed to choose points within the visible region or on the bold lines. Now remember, we can choose points on the bold lines and also points within the visible region, within this triangle here. But one thing that you should keep in your mind is, if the line is dotted, you don't choose points along dotted or broken lines. We only choose points along bold lines, and where a bold line meets a bold line. Where a bold line meets a dotted line, we don't choose points along there. Or where a dotted line meets a dotted line, you don't choose points along those lines. So we only choose points along a bold line or inside the visible region. So just to keep time, because I tested all these regions after doing the number on a graph, and I'm just going to tell you that one of the ways of doing this simply is by choosing corner points. You can decide to choose corner points. For instance, for me, what I'm going to simply do is that I am going to choose this point here. I'm going to choose this point here. I'll choose this one here. That is, I'm going to choose the point of 80 on x-axis and 0 on y-axis, and then also 150 on x-axis and 0 on y-axis, and also this point here, which is 80 on x-axis and 90 on y-axis. And then there was also another point that I had found. I don't remember that point, but I'm going to tell you when I remember it. So you can choose the corner points, and then the coordinates of these corner points is what we are going to input into our objective function or our profit expression, so that we can find out how much profit, the maximum profit that the tailor can make using a certain number of uniforms. Remember, we want to find out the number of uniforms, the number of sets of uniforms that the tailor can make in order to maximize profits. So what you're supposed to do is that you're supposed to choose points within the visible region or along the bold lines, and these points here are very many. You can choose points anywhere. You can choose this one, you can choose this. So the points are very many, and I don't want to choose all these points and then we begin to test them. But because I had tested all these points earlier, I'm just going to give you the results that I was able to come up with. You can go and do this number on a graph paper, and you pin in the comment section what you got as your answer, whether it's going to correspond with what we are going to have here, or maybe there's some contradiction, so that all of us can be corrected together. So as I told you, you have to choose points within the visible region or along the bold points. Now for me, these are the points here which I have chosen, the ones that I have circled here, and also here, these are the 4 points that I have chosen. So these are the points that we are going to substitute into our objective function or our profit expression, so that we can be able to find out how much profit she is to make if she is to produce sets of numbers of uniform according to those coordinates that we have chosen. So in our table here, we have the number of uniforms represented by x and y. So here the first column consists of the x values, the second column consists of the y values. So now we have to substitute these values of x and y into our objective function or the profit expression, which is 8,000x plus 6,000y, because it said she makes a profit of 8,000 on each set of boys uniform and a profit of 6,000 on each set of girls uniforms. So that means basically we are supposed to get here, for this case, for the first one, we are supposed to get here 8,000 multiplied by the value of x, which is 80, plus 6,000 times 0. So what are we going to get? We are obviously going to get 640. If you were to put this on your calculator, we are going to get 640, because here we are having 8,000 times 80, which is equals to 640. So here we have 640,000. And then after that, we are also going to have here, we are going to substitute this value of x 90 into our profit expression here. So we are having here 8,000 times the value of x, which is 90, plus 6,000 times 80. So when you simplify this one here, what you're going to end up with is 1,200,000. Remember, the amount that we are having here, this is money. Money is in shillings, okay? The units are paramount. Never forget units in mathematics. They are very essential. You can forget units and then you lose marks because of forgetting units. So now we also go to our next one. Here we are going to have 8,000 times the value of x here, which is 150. What we are going to get is 1.2 million as well. I did this earlier. The reason as to why I only chose this specific 4 points is because I want to show you that these last 3 values here are giving you the maximum amount. Even if you're to pick any other coordinates on the graph above, you're going to find out that all of them are less than 1,200,000. So if we also get this one here, we shall have 8,000 times 120 plus 6,000 times 40. So what we are also going to get here is going to be 1,200,000. So when you are to test with all the other values, what I want you guys to do for me is this. I want you to try out this number on a graph and you pin for me in the comment section what you got, because depending on the scale that different people use, they will get a different maximum value. So please do this number and you pin in the comment section what you got as your maximum profit for the tailor. So now when we look at this, what are we seeing? We are seeing that there are what we are seeing is that there is 1,200,000 appearing 3 times for 3 different sets of uniforms. This one here, the first one is here, the second one is here, and the third one is here. Meaning that if the tailor is to produce, 90 boys uniforms and 80 girls uniforms, the tailor will get 1,200,000. The same thing if the tailor is only to produce 150 uniform for boys and 0 for girls, you also get 1.2 million. And the same for the third scenario. So now when you reach such a case, what are you supposed to do? Because now this is what is giving us the maximum profit that the tailor is to make. And we have figured out that the maximum profit that the tailor is going to make is 1.2 million. But there are 3 different categories or sets of uniforms for boys and girls which can give us that same maximum profit. So as a learner, what do you do? Me, what I usually do is I just write all 3 of them. I just write all 3 of them in my conclusion. However, you can decide to choose one which you feel is the best. Now for me in this case, I would say the first one here is the best. This first one is the best according to me. Reason being, the tailor wants to make uniforms for both boys and girls. That means that the uniforms should at least try to be even, you get it? For the second scenario, though it will give the tailor the maximum profit, she will only have made uniforms for only boys and not girls. Meanwhile, for the first scenario, the uniforms are somehow balanced. So you can decide to choose one of the values, you can still be scored. But for me, what I usually do is I write all 3 of them down, because all 3 of them can give the tailor the maximum profit, and they have not specified for us that we should choose the sets of uniforms basing on a certain criteria. They just wanted us to find out which sets of uniform for boys and girls can give us the maximum profit. And since these 3 different sets can give us the maximum profit, me, I usually just write all of them there. So now what are we doing? We have to give our conclusions. I told you conclusions are very paramount in this curriculum. It is an application of your response to the item. So now let us give our conclusion. So therefore, the tailor should make 90 and 80 or 150 and 0, or 120 and 40 sets of boys and girls uniforms respectively, in order to make maximum profit of 1,200,000 shillings. So you can decide to give your conclusion in this way, or you can decide to choose one which you feel is the best. And me, I told you, according to me, I think the first one here could probably act as the best, because since she's making uniform for both boys and girls, it is considerable to make uniforms in a balanced manner. You understand? Or you could just decide to give the teacher all the options, since they just wanted to know which sets of uniforms to be produced. They have not specified which is the best or not, as long as the sets of uniforms can give the maximum profit. So thank you so much for watching this video. If you've come this far, it means that you really love the content on this channel and it's adding value to you. So please smash that like button and the subscribe button if you have not yet subscribed, and please put your comment in the comment section. It really helps us with engagement, so that we can know what your opinions are, what your questions are. Let us share this video with our friends and other people out there that need it, so that we can reach as many candidates and new curriculum students as possible. Let us work together to turn our academic struggles into strength. Believe me, if you stick to this channel, we are going to excel together. Thank you so much for watching this video. This is what we have done so far. This is how far we have come today, and we have managed to solve item 2 of UNEB. So thank you so much for watching this video. May God bless you. Stay blessed. I remain Patrick Oliver.